right, so this is the screencast for nomenclature objective number 3, which in this you're actually going to learn how to name binary ionic compounds, all of them. Whether it is a type 1 or a type 2, also sometimes called a type A or a type B binary ionic compound, but you are going to be able to name all of them by the end of this objective using valence electrons and the stock system. So our essential question, how are names and formulas written for binary ionic compounds with representative and transition metals? Representative metals are what you've been working with, also known as type 1 or type A metals. They're the ones in column 1, 2, and 3 where you know their valence electrons. The transition metals, they're also known as type 2 or type B metals, and they're ones where you just don't know their valence electrons or what charges they form. So we have to have different rules for them. So that's what this objective will take us through. So the first thing we're going to review is just binary compounds. It means two. Bi means two, so these are compounds with only 2 elements. So you're not going to see 3, 4, 5 elements in these first compounds. There are 4 types of binary compounds you will learn. Binary ionic with 1 cation type. Binary ionic with many cation types, that difference between type A and type B. We're going to cover both of those in this objective. And then in objective 4 and actually objective 5, we're going to cover molecular and binary acids. So just a quick review to review where metals and nonmetals are located on your periodic table. This staircase divides them, so these are all metals. So if we're dealing with an ionic compound, you're going to have a metal first and nonmetal second. And you also might want to make sure that you have all of your valence electrons or your oxidation numbers. Everything in column 1 is a 1+, everything in column 2 is a 2+. These guys in here, they're the transition metals. We don't know what they form, so they're these. They're the type B metals. And then these guys right here are the 3+. So label your staircase if needed. I've kind of outlined where that would go to separate metals and nonmetals. Okay, so our type 1 or type A metals, your first type of compound to learn how to name, binary ionic compounds. These are the metals that form only one type of cation, so only one ion. They're going to be in column 1, 2, and 3. Column 1 forms a 1+ ion. Column 2 forms a 2+ ion. Column 3 forms a 3+ ion. These are actually the ones that you have been working with because we know their oxidation states. So the basic naming rules for them. You're going to name the cation like the parent name. It's just going to stay the same. So like sodium chloride, the first word, sodium, just stays the same. The anion, the second word, is what you're going to keep the root of the parent name and just add IDE to it. So we're combining our rules for naming a positive ion and a negative ion together to make a compound name. You can capitalize the name of the cation, but it's just not necessary. Don't capitalize the name of the anion. You'll just sometimes see different symbolism. So these are pretty easy to do, and I've given you some examples. This has sodium and it has chlorine in it. Well, it's sodium bonded to, or sodium ion bonded to the chlorine ion, which is sodium chloride. We change the ending to IDE. CaBr2, the formula for that, or for this particular compound, the name of it is calcium bromide. Instead of calcium bromine, I changed the ending to IDE to show that I have the ion. Magnesium nitride, Mg3N2. Li2O is lithium oxide. So instead of lithium and oxygen or lithium ion and oxygen ion, I'm just combining lithium with oxide to get the name. So these are pretty easy to name. And notice this one's in column 1, this one's in column 2, this is in column 2, and this one's in column 1. So these follow these nice, neat, simple rules because they're in column 1, 2, and 3. So how do you write the formulas for them? You've actually already learned how to do this. This is what we just did practice with, were these simple, easy ones. Binary ionic compounds, type A or type 1 metals. You use the periodic table to determine the oxidation numbers. So their oxidation charges of the metal and the nonmetal. And remember, the positives and negatives must balance out. You've previously worked these out. So here's some other examples for us to do. You can try these in your notes. Go ahead and write down the names of the formulas. Put these in your notes. You can do these at this point if you want to, or you can wait for us in class if you need more help. potassium oxide, calcium fluoride, potassium bromide, potassium chloride, sodium fluoride, magnesium sulfide. So I've given you the names. I want you guys to write the formulas for them, and we're going to practice doing both, writing names and writing formulas. Now let's talk a little bit about ones that we haven't talked about yet, or when things get kind of tricky, because we have to come up with a new system. So binary ionic compounds, when you have a type 2 or a type B metal, these are your transition and intertransition metals that are not in column 1, 2, and 3. So if you look on your periodic table, you don't have charges marked for them. These metals form multiple cations, so we don't know what they form. For example, iron forms 2 cations. Iron specifically can form Fe2+, and it can form Fe3+. If you just look at a compound name and you look in the periodic table, you can't tell which one it's talking about. Are you dealing with iron 2 or iron 3+? You don't know. So we have to have some other system. For example, I give you copper chloride. If I said write the formula for copper chloride, you're like, well, that's great. I know chlorine has a 1- charge, but copper's not in column 1, 2, or 3. So you don't know the charge of it. So this naming system we have doesn't help us very much. It doesn't tell me what the charge of copper is, so I can't write my formula if I don't know the charges. Well, lucky for you, we have a system. IUPAC has developed a system to help us out. When you are naming these compounds, you're going to use what's called the stock system. In the stock system, the charge of the cation is designated by a Roman numeral in parentheses after the name of the metal and before the name of the nonmetal. So if you just look down here, I've given you an example, iron 3 chloride. So in parentheses, I have a 3. That 3 tells me that this iron is a 3+. So the Roman numerals that can be used, I've just gone through and given you 1 through 10, what the common Roman numerals are. So just in case you don't know what the Roman numerals are, these are the ones that you'll primarily use the most. But you must remember that the Roman numeral tells you the charge of the metal, not the number of atoms. And you are only going to use the stock system when you have a metal that is not in column 1, 2, or 3. You will only use the stock system for a type 2 or for a type B metal. You will not use this in our previous examples where you know the charges. So I've given you just some little examples down here: copper 1 oxide, copper 2 oxide, iron 3 chloride. So you know this has copper and oxygen in it. You'll know the charge of oxygen because of the periodic table. And this tells me that, that this particular copper has a 1+ charge. So I can now write the formula for it. Copper 2 oxide, this tells me this particular copper has a 2+ charge. So it has lost 2 electrons to form a 2+ charge, and I can now write the formula for copper 2 oxide. Iron 3 chloride, I know chlorine's a 1- from the periodic table. This iron is specifically a 3+ charge, so I can write my formulas based off of that now. If you take out this Roman numeral in here, I can't write the formula because I don't know the charge. So this is what I've outlined right here. Copper has a 1+ charge, oxygen has a 2- charge, so I literally just balance the charges to write their formulas, Cu2O. So I need to have 2 coppers to balance out the 2- charge of the oxygen. Copper 2 oxide though, that copper has a 2+ charge, oxygen still has a 2- charge, so the formula for copper 2 oxide is CuO. These are 2 totally different compounds. And copper can do this just depending upon the situation that it's in. These 2 compounds, iron 2 chloride and iron 3 chloride, they're 2 totally different compounds with completely different properties, different boiling points, different melting points, different properties completely, but it just depends on how many valence electrons iron loses on what particular ion it forms. Iron in this particular case is going to have a 2+ charge, so it loses 2. Chlorine always has a 1- charge, so FeCl2 is my formula. You just balance out the charges again. Iron 3 chloride, iron has a 3+ charge, chlorine has a 1- charge, so again, you just balance the charges, FeCl3. So these 2 formulas are different because iron has a different charge. So leave some blank areas. I would say maybe 4 to 5 more lines for just some practice. If you would like, if you feel you've got this, then you don't necessarily have to worry about it. But I would leave just a few lines for more practice problems that we're going to do in class. So our next slide shows you a few exceptions. There are a few transition or intertransition metals that do only form one cation type. And I know this is confusing, but the natural system is not to use the stock system when something only forms one cation. So you just have to memorize the charges for them. And you might even jot them down on your periodic table, like in the box for zinc. You might write down a 2+ ion because zinc always forms a 2+ ion. So you're not going to see like zinc 2 oxide in its name down here. You'll just see zinc oxide wrote down. And they're just expecting you to memorize that zinc forms a 2+. Silver always forms a 1+ ion. So again, the same thing. They probably won't use the stock system a lot for silver. You can use it, it's perfectly fine, but you're going to see it a lot of times not used just because silver only forms a 1+ ion. When you have an ion when you have a metal that only forms one cation, there's really no purpose to using the stock system at that point. So the second part to this, so that was writing the formulas. Now, how to write their names. When you're writing the names, it's a little more complicated to do because you have to use the known charge of the nonmetal to then calculate what the metal charge has to be. So for this example here, I have SNO. Well, we know this is tin, and I know this is oxygen. Looking on my periodic table, I know oxygen has a 2- charge. I don't know what tin has, but I do know that I only have one atom of oxygen, so I only have a 2- charge. So then you go, what does that tin have to be? To balance it out, that tin has to be 2+. So the name of this would be tin 2 oxide. If I look at the formula SNO2, this is a little bit different. Oxygen still has a 2- charge, but now I have 2 of them, making my total negative charge 4. So because I only have one atom of tin, what does that one tin have to be? It has to be a 4+ charge so that I have 4 positives and 4 negatives to balance them out. So in this example, tin is now tin 4 oxide. And you can see down here that we've got a 4 in parentheses in between the tin and the oxide. So when you're naming them, when you're writing the names, you actually have to use the formula. You have to use the known charge that you do know, which is always going to be your nonmetal, to kind of back calculate what the metal has to be. So here's some examples. Cr2s3. I know that when I'm writing the name for it, I know that sulfur has a 2- charge, just judging by the periodic table. But if I have 3 of them, I have a total negative charge of 6. So I have to have a total positive charge of 6+. Well, what times 2 would give me 6+? 3+. So the chromium here has to be chromium 3 sulfide. And we'll work through more examples of this in class. I just want you to get some of them down in your notes because some of you are going to pick this up very quickly and not need any more examples. The next one, or the last one we'll work through, is gold bonded with sulfide. Sulfur has a 2- charge, just judging by the periodic table. Gold must have a total of 2+ to balance out the 2-, but because I have 2 of them there, each gold has to be a 1+ ion. So I have a 1+ and a 1+ giving me a total of 2+ to balance out the 2- of the sulfur. So the gold would have to be gold 1 sulfide. So go ahead and leave 4 or 5 spaces in your notes for more examples. You can leave some space for more examples on how to write the formulas and how to write the names. The summary for this objective is going to be a 20-word summary, and we will do that in class, so there's no need to worry about that. The very last slide for this tells you to write a level 3 test question on the left side of your notes related to naming or writing formulas for the compounds we've covered so far. So the binary ionic type 1, binary ionic type 2. We are going to create a foldable in class. It's going to kind of be your cheat sheet or your guide for all these different compound types. So we will create this in class. And we will work more examples on whiteboards and in class, and you're going to do a bunch of practice problems. So that's what we will spend the whole block doing, is just practice problems.